This video contains the solutions for the second two free response questions from the 7172 packet. So let's see. We've got two functions, f and g. They're given by e to the x and natural log x. I'm going to make a little sketch of that. You could use your calculator, but you know what those look like. Come on. You know what these look like, right? They're inverses of each other. Natural log function and the exponential function are inverses, right? That's 0.0110. And they want, find the area of the region enclosed by the graphs of f and g. This is f, this is g, between x equals 1/2 and 1. And that would be this. Oops, sorry, 1/2 and 1, right. They didn't say in the first quadrant, so it would extend down to here. Right, that region right there. Alright, so part A, what is the area of that? That is the area from 1/2 to 1. The top function is the e to the x. And it's natural log x dx. You could do that by hand, although remember the antiderivative of natural log x involves integration by parts. But anyway, calculators are allowed on this one, so let's do it that way. So we go math 9. I've got e to the x minus natural log x, comma x, comma 1/2, comma 1. That's like 1.223. Agrees with the rubric. They gave 2 points for this problem. One for this, another one for that. Alright, part B. Find the volume of the solid generated when that region is rotated around the line y equals 4. So y equals 4 is up here. So that means this will be the outside one, this will be the inside one. We're rotating around like that. So that's pi times the integral from 1/2 to 1 of the outside function. That's this one is the further away. It's natural log of x squared minus, oops, I forgot that minus 4 again, right? Since we're rotating around y equals 4, that's got to have a minus 4 in there. E to the x minus 4 squared dx. And let's see if we can get that into our calculators. So I'm going to put the pi out there so I don't forget. Pi times math 9, the integral, let's see, so I've got the natural log of x minus 4 squared minus e to the 4, e to the 4, whoops, whoa, e to the x minus 4 squared, just checking my parentheses there, comma x, comma 1/2, comma 1. See how we did there. 23.609 agrees with their rubric. Great. 23.609. That was worth 4 points. The pi and those two numbers was worth a point. You got 2 points for having this stuff right, and then the final point for the answer. Part C. Let h be the function given by this one minus this one, so it's the difference between those. Find the absolute minimum value of h of x on the interval here, and the absolute maximum value on the interval. So we have to check. Let's see what it looks like. Let's just graph h of x. So the h of x function is f minus g. F is e to the x minus g is natural log of x. And we're only care about from 1/2 to 2. So let's just get our window down to that. from 1/2 to 1, sorry. 1/2 to 1. Might have to change my y values. I don't know what I had them set at. Yeah, that doesn't look very good. Let's try that again. Window. So I need bigger y values. I know that they're always positive because this function's above that one, so let's go 0 to 4, something like that. All right, so it looks like it's hard to tell. Let's say this is from 0 to 4, so let's narrow it in from 2 to 3. To 3. Yep, there it is. Yeah, I thought there might be a little minimum there. Okay, so the h of x function has, that would be a relative maximum at the endpoint of that interval. Then it goes down. That's its absolute minimum, and that's its absolute maximum. Right? So let's see. Remember, you have to check when they talk about closed intervals, we have to check endpoints. So absolute minimum and absolute maximum. Absolute minimum is at x equals, let's see, second calculate the minimum. Oh, I should have just typed in, I should type in 0.5 and 1, that's faster. 0.567. But they want the value of the function, right? Remember these, you got to watch out which they're asking for. They're actually asking for the value. The function is 2.330. 2.330. And then the absolute max is at x equals 1. It's at the edge of the interval, right? And that's what we get when we plug in. That would be, let's see, which is on the top is e to the x, so that'd be e to the 1 minus the natural log of 1, so that would just be e. Right? How do we justify that? We have to justify that looking at the derivative. So the derivative here, h prime of x, would be equal to the e to the x is its own derivative. The derivative of g is 1 over x. And find the zeros of this. This is equal to 0 at 0.567, which we already found. And then we just need to check x equals 0.567 and the endpoints. At x equals 1/2 and x equals 1. Right? All right, last one. Let f and g be the functions given by these. Excuse me. The graphs of f and g are shown here. It's like they intersect at 0 and 1. Find the area of the shaded region enclosed by f and g. Okay, so that's the integral from 0 to 1 of the f function, 2x times 1 minus x, minus the g function, which is 3 times x minus 1, so the square root of x dx. Calculator's active. So you should put that in your calculator and should get, I'll let you try that, 1.133. 2 points for that one. 1 for the setup and 1 for the answer. In B, we want to find the volume of the solid generated when this region is revolved around the horizontal line y equals 2. Okay, that's up here. So that means the g of x function is going to be the outside one now. So it's going to be pi from 0 to 1 of the g of x function, 3 times x minus 1 times the square root of x, minus, what are we rotating it around? 2. Minus 2 squared minus the inside radius, which is 2x times 1 minus x minus 2 squared dx. Let's jam that all into your calculator, and you should get 16.179. All right, the last one. Let h be the function given by h of x is equal to kx times 1 minus x. For each k greater than 0, the region not shown enclosed by the graphs of h and g. So it's almost like they've just tweaked this. Instead of making this a 2, they're just going to make it some value k. But notice that it still intersects at the same points, right? If you make that a k, it still has zeros, 0 and 1. And they want to know is the base of a solid square cross sections, and there's a value of k for which the volume of the solid is equal to 15. Okay, so each one of my cross sections now is the side of a square, and each side of that square is the top function, which is now k x is 1 minus x minus the g function, which is 3x minus 1. It's the square root of x. So the area of this, we want to integrate from 0 to 1. The area, it's this whole thing squared. That'd be kx times 1 minus x minus 3, so x minus 1 times the square root of x, all squared. That's the area of that square. And we want that to be equal to 15. That's it. And they gave 3 points for this part. They gave 2 points for this, and 1 point for having the whole answer, including the right numbers here, and having it in an equation equal to 15. All right.